Hello, my name is Elias and I will be your host in this part of the program, which is the presentation of descriptive statistics, and this is part of the business maths program. In this video, I'm going to demonstrate on how you can present your data, making it ready for interpretation and so as to allow for good decision making. Now, there are two types of presentation that we're going to cover in this video. The first one is the tabular presentation, or using the tables. For example, you can talk about the frequency distribution tables. Frequency distribution. The second type of the presentation that we are going to look at is that of graphs, using the graphs. For example, you can talk about the dot diagram. You can also talk about the histogram. We can also talk about the bar chart. Okay, etc., etc. So you have the bar chart, you have the stem and leaf plot, you will have the box plot, and so on. So in this video, we are going to use the tables as well as the graphs to present our data. Let's first start by looking at the frequency distribution. Okay, so under frequency distribution, what we are saying is that given a collection of data values, then the specification of all the distinct values in the collection, together with the number of times each of the values occur in the collection, is called a frequency distribution. Now, what we are seeing here is that we will have different values, different distinct values, and some of these values will be repeated. For example, you can look at data, say 4, 3, 1, 2, 8, 9, 5, 3, 1. So from here, we see that we have distinct values, but some of these values are repeating. That's why here, when we are looking at a frequency distribution, we want to look at the distinct values that we have along with the number of times that each distinct value is appearing in a collection. And from here, we see that 1 is appearing 3 times in this collection. So we have the 1 here, we have the 1 here, we have the 1 there. And when we look at the 2, we only have 1, the 3s are 2. So all these values are distinct, and we can actually present this information using a table which we call the frequency distribution table. Now let me just clear this, and then we look at an example and see how we can present the data using a frequency distribution table. Okay, so I will write the question on the board, then we can construct the frequency table together. Okay, so we're saying construct a frequency distribution for the following data. For the following data, okay, for the following data which represent, data which represents the number of breakdowns. The number of breakdowns. Okay, for each track. For each track. For each track. This is you. We're talking about a truck, a car. I mean a vehicle. Track in a fleet. In a fleet of 20. In a fleet of 20 trucks in 1 year. Fleet of 20 trucks in 1 year. Okay, so we have this question and the data for those trucks. That's the number of breakdowns. So we have 6, we have 11, we have 5, we have 1, we have 6, and another 6. We have 7, we have 5, we have 7, we have 6, we have 1, we have 7. And then we have 5, we have 3, we have 6. We have 3, we have 5, we have 7, and then we have 6 and 6. Okay, so these are the distinct data points that we have, and each of these data points has the number of occurrence in this collection of the data. So now what we need to do then is for us to construct a frequency distribution for this data, which is telling us about the number of breakdowns for each truck in a fleet of 20 trucks in 1 year. So we see that each a certain truck had the 6 breakdowns, the other one had the 11, and so on. So what we need to do for us to be able to construct a frequency distribution, we first need to know the tally, to do the tally mark. So we will construct a table, and then we are going to put in the tally marks. So I urge you, please copy these data points so that I can clear the board, and then we construct a frequency distribution table. Okay, so I have shifted the data points, so I've put them here, so we can use those data points to construct our frequency distribution. So the first thing that we need is for us to know what what the headings for each column will be. So the first one will be, because we're looking at breakdowns, so we'll have number of breakdowns. Okay. Then we will have a tally mark. And then we will have the frequency. So from here we see, we can look at the numbers. So we have the 1. The 1 is represented. Do we have a 2? There's no 2, but there is a 3. Okay. Do we have a 4? There is no 4, but there is a 5. There's a 6, 7, and then 11. Okay, so that is 1, 3, 5, 6, 7, and 11. So from here, we can look at the number of times that 1 is appearing. So if you look at this data, we only have 2 1s. So with tally mark, you tally 1, 2, and then it means your frequency is 2. So when we go to 3, we count how many 3s we have. So we have 1, 2. So we have 2 3s, so 1, 2. So we put 2 there. We go to 5. I can see a 5 there in the first row. So 1. I go to the second row. I see another 5. 2. I go to the third row. I see 2 5s. 3, 4. In the fifth, there is no 5. So meaning the frequency for 5 is 4. I go to 6. I start with the first row. So there are 3 6s. The digit 6 is appearing 3 times. So 1, 2, and 3. So I'll put 1, 2, 3. I go to the second row. I see there is only 1, 6. So I put 1 there. I go to the third. There is another 6. Now with tally mark, so I have tallied 4, meaning the fifth one crosses here. So we put them in bands of 5. So meaning this tells us that there are 5 digits, which I mean 6 here appearing. Then we go to the last, we see 2. So it means the frequency for 6 is 7. So we have 1, 2, 3, 4, 5 crossing, 6, and then 7. We go to number 7. First row, we don't have. Second row, we have 3. So 1, 2, 3. Fourth row, we have 1. So 1. Fifth row, we don't have. So meaning these are 4. We go to the number 11. There's only one 11, which is in the first row. So we put 1 there and put 1 there. If we check this to get the total frequency. Okay, so we have our 20 there. So this is how we construct a frequency distribution. Okay, so from this, we can also obtain a relative frequency distribution table from the data that we have. So clearly, just where we are, we can simply just include another column, which will call relative frequency. So relative frequency. Now this relative frequency is measuring the proportion of each of these distinct values in the distribution. What's the proportion of 1 in that collection? What's the proportion of 3 in that collection? And so on until we reach the last part where we want to get the proportion of 11 in that distribution. So to do that, it means that now that since we know what our total frequency is, we will be dividing the frequency for each distinct value divided by the total frequency. So if we do 2 divided by 20, we will get 0.1. 2 divided by 20, we will get 0.1. 4 divided by 20, we will get 0.2. 7 divided by 20, we will get 0.35. 4 divided by 20, let me close here. Okay, so 4 divided by 20, we will get 0.2. And 1 divided by 20, we will get 0.05. And if I add this, I should get a 1. So the total relative frequency, when you add all the relative values, you should end up with a 1. So if what you get here is more than 1, it means you need to counter check your scores, or rather your probabilities that you have computed, or the representation for each number. Therefore, the total relative frequency should be 1, which will also inform you that what you have done up there is correct. So this is the relative frequency distribution table, which will have the last column showing the proportion of each distinct value in the set of, in the collection of the data points. Okay, so what we have looked at is the ungrouped frequency distribution. We can also look at a grouped frequency distribution table. Now, when you are using grouped frequency distribution, we mainly bring it in if we are dealing with a large data set. So if you have too many data points in the collection of data, you do well to use a grouped frequency distribution so that you don't have too many points listed in your table. Now let's take an example of how a grouped frequency distribution will look like. Okay, so I'll write the question on the board. So construct a grouped frequency distribution. Construct a grouped frequency distribution for the following. For the following data, which represents the scores of 40. The scores of 40 students in a statistics test. In a statistics test. Okay, so we want to construct a grouped frequency distribution for the scores of 40 students in a statistics test. Now these scores are, so we have 46, 49, 50, 53, 54, 55, 55, 57, 58, 59, 59, 60, 62, 63, 64, 65, 65, 66, 66, 66, 66, 68, 68, 69, 70, 71, 71, 72, 73, 73, 73, 74, 76, 78, 79, 80, 82, 83, 84, and 88. So these are the test scores for 40 students who wrote a test in a statistics course. Now what we need is, looking at the data points, there are too many. So what we need is for us to construct a grouped frequency distribution. Just like in the previous example, please copy these points here so that I can wrap and then construct the frequency distribution table. Okay, so in constructing a grouped frequency distribution table, I will use class marks. So I will first look at the groups that I want to create. So I will create groups of of interval 5 in each. So what we'll have, I will look at the smallest value that I have, which is 46, meaning I can start from 45. So let's have scores here. Okay, then again we have tally mark or marks, and then we have the frequency. So we start from 45. So from 45 to 49, we have 50 to 54. Then we have 55. Let me bring it down here. 55 to 59. We have 60 to 64, 65 to 69. We have 70 to 74. We have 75 to 79. We have 80 to 84. And finally 85 to 89. So if you look at the largest value that we have in the distribution, we have 88. So 88 will be able to fall in that category. So if we look at the data points, so maybe let me just write them down here again. We can shorten this so that we have enough space. So we had 46, we had 49, we had 50, 53, 54, 55, 55, 57, 58, and 59. So again 59, we have 60, 62, 63, 64, 65, 65, 66, 66, 66, 66, 68, 68, 69, 70, 71, 71, 72, 73, and 73 again here. We come down, we continue, 73, 74, 76, 78, 79, 80, 82, 83, 84, and 88. So those are the data points that we want to put in this frequency distribution table. So we look at the first class that we have. The class consists of all the scores from 45 to 49. So if we look at here, we only have 46 and 49 falling in that class. So we have 1, 46, and then 49. So meaning the frequency there is 2. Then we go to the second class, 50 to 54. If we look at this, we have 3, so 50, 53, and 54 falling in this class. So 1, 2, 3, meaning our frequency there will be 3. We go to the next class, which is 55 to 59. So we go to 55 here, all the way to 59. We have 1, 2, 3, 4, 5, 6. So it means we have 1, 2, 3, 4. Remember, we cancel here to mean 5. We cross, and then the 6th one. So our frequency will be 6. We go to the next class. So we have 60 to 64. So we start from here. We count how many 4 in that class. So 1, 2, 3, 4. So there are only 4. So 1, 2, 3, 4, and then we put a 4 there. Next, we go to the next class, which is the 65 to 69. So we come here, 65 starts from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 which fall in this class. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 candidates scoring in that class. Then we have 70 to 74. So we come here, so 70, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 students who scored in that range. 3, 4, 5, 6, 7, 8. Then we put 8 there. 75 to 79, we come here again. So we don't have 75, so we have 76. So 1, 2, 3. There are only 3 candidates who scored between 75 and 79. So 1, 2, 3, and we put a 3 there. We go to the next one, which is 80 to 84. So we look at this distribution. So 1, 2, 3, 4. There are only 4 students who scored between 80 and 84. So we have 1, 2, 3, 4, and we put our 4 there. And if we look at the last class, which is 85 to 89, there is only one, which is 88. This value here, this is 88. So we put a tally mark of 1 and put 1 there. Then we can close and put a total. Our total is 40. So this is how we construct our frequency distribution. So I will end here. In the next video, I will show you how we construct the graphs using these same data points. And I will look at, we'll start by looking at a dot diagram, then move to a frequency distribution. Please make sure you subscribe to the channel Elias Muau, which is a YouTube channel, so that the next time I post a video on YouTube, you will get an automated update. See you in the next video.